Hiya, right? This is a lesson on how we solve linear equations by isolating the term. So what we're going to do in this lesson is we're going to look at how we can kind of undo the algebra that's going on to try and get back to an unknown value. In this case, it's going to be x. So if you look at this first equation, we've got 3x minus 5 equals 13. We're trying to get back to x. So at the moment, we've kind of got to get rid of that minus 5. And the way in which we're going to do that through balancing is we're going to add 5 to both sides of the equation. And the idea with balancing is whatever you do to the left-hand side of an equation, as long as you do the same thing to the right, it keeps it equal and therefore is an equivalent line. So if you add 5 to both sides, on the left-hand side, your simplified expression is now just 3x, and on the right-hand side, you have 18. So if 3 lots of x equals 18, then what we have to do to find 1 lot of x is we have to divide by 3 on both sides. And if you divide by 3 on both sides, you get a statement of x equals 6. And that is our solution. We can always check that by substituting it into the original expression. So 3 lots of 6 makes 18, and then if I take away 5, it makes 13. So I've just checked that, and now I know for sure that x equals 6. For the second line, same sort of idea. We've got to try and isolate the x first of all. So at the moment, that plus 2 is separate to the x term. So what we're going to do is we're going to subtract 2 from the left-hand side, which means we have to subtract 2 from the right-hand side also. And what that leaves me with on the left-hand side is x divided by 5. The plus 2 and the minus 2 cancel out, and on the right hand side, I'm left with 1. Now, at this point here, we've got to think about the idea of undoing divide by 5. So I think we have to times by 5 on that side, but if I'm going to do 5 times the left hand side, I have to times the right hand side by 5 also. So times by 5 and divide by 5 cancels out, which leaves you with x. And on the right hand side, we're left with 5. So x has a value of 5. And if we check that, substitute x is 5 into the equation, 5 divided by 5 gives us 1, and add 2 gives us 3, and that works. So we know again, that is correct. Slightly more challenging now is if we've got a set of brackets involved. Now there is more than one way to do this, but what I'm going to do here is expand the brackets out. So that means everything inside the brackets is going to be times by 2. So 2 lots of 2x makes 4x, and 2 lots of 3 makes 6. Now I don't have to do anything to the right hand side because all I've done there is multiplied out the brackets. The next thing I'm going to do is try and get rid of the plus 6, which means I'm going to subtract 6 from both sides of my equation to make it balance, which leaves me with 4x and 28. Then if I divide by 4 on both sides, then what I get is an x value of 7. Okay, and the final working, you'll notice here, this is a bit more complex still because we've got a single term with x within it. So at the moment, I'm dividing everything by 5 to get an answer of 4. So what I'm going to do this time is times that by 5 on the left-hand side and times by 5 on the right-hand side. And by doing that, if I'm timesing 5 and then divided by 5, they're going to cancel out, which leaves me with 2x plus 4. And on the right-hand side, that leaves me with 20. Then what I need to do to isolate the x term is I need to get rid of that plus 4. So I'm going to subtract 4 from both sides, which gives me 2x equals 16. And then the final step is to divide both sides by 2, again balancing, which leaves me with 1x, or just x, it's a better way of saying it, equals 8. And again, we could substitute that in to check it works, but I'm sure it does. We're all good, and that's our solution for x.